Hey everyone, welcome to this explainer. Okay, so when we talk about C-sharp system architecture, security isn't just about, firewalls or encrypted passwords. It's literally woven right into the code itself. Today, we're zooming in on a really fundamental choice every .NET developer faces: how to manage communication between classes. We're going to see how one tiny architectural misstep can basically leave your entire system's internal state completely exposed to hijacking, and exactly how to lock it down tight. So let's jump right in.
Here is the central question for us today. Why exactly are public delegates considered a systemic vulnerability? I mean, if you're building a system where different components have to talk to each other, you obviously need a way to pass instructions around. But what actually happens when you leave functional pointers, the literal triggers for your core system behaviors, just sitting there exposed to the public? Honestly, understanding this is one of those light bulb moments that separates junior coders from senior architects, and it all comes down to how C# handles dynamic method execution.
Okay, let's get our baseline straight. A delegate in C# is basically a type-safe, object-oriented function pointer. But what does that actually mean when you're writing code? Well, think of it as a dynamic wrapper around a method. Instead of hard-coding a direct call to a specific method, you assign that method to a delegate, and then you just call the delegate. It's incredibly powerful, right? It lets you pass methods as arguments, which gives you callbacks and dynamic functional programming. It's basically a variable, but instead of holding data, it holds a behavior.
And here's where the real power kicks in. Delegates don't just hold one single method. Let's think of it like a VIP contact list. A delegate can act as a multicast delegate, storing a whole bunch of method references all at once. First, you add methods to this list using the += operator. Second, C# does its magic and combines them behind the scenes. And third, when you finally invoke that delegate, it just goes right down that VIP list and calls every single method one by one. It's a super efficient way to trigger a whole chain of actions from just one command.
Now, C# is awesome because it actually gives us these built-in generic delegates right out of the box, so you don't have to declare your own from scratch every time. We've got func, which you use when your method needs to return a value. You've got action for when your method takes parameters but returns void, so it's just executing a task. And then there's predicate, which always returns a Boolean, perfect for checking conditions like, seeing if a number is even. These are fantastic, absolutely essential everyday tools. But this is exactly where we run into a massive problem.
Part 1. The vulnerability hijacking the invocation list.
So, what actually happens if you make that VIP list public? Well, if a delegate is publicly accessible inside a class, you are basically leaving the master control switch sitting out on the sidewalk. We've got two main threats here. First, unauthorized wipes. Any outside class can come along, use a simple equals operator instead of +=, and literally overwrite the delegate, completely wiping out every other subscriber on the list. And second, unauthorized invocation. An external class doesn't even have to wait for an event to happen naturally. It can just maliciously, or even accidentally, force an invocation, triggering internal system calls completely out of nowhere.
And you can probably guess, this kind of open access leads straight to state corruption and wild, unintended side effects. It completely shatters fundamental object-oriented programming principles. A core rule of OOP is encapsulation. A class has to protect its internal state and only let things change through really tightly controlled channels. By exposing a raw delegate, you are failing to protect that state. If some rogue class can just fire off your app's core logic or delete the callback list, your system is going to be unpredictable, buggy, and an absolute nightmare to maintain safely.
All right, moving to part 2. The security patch, the event keyword.
Okay, so how do we fix this? We clearly need a way to keep all that awesome power of multicast delegates, but we have to lock down who gets to invoke the list and who gets to wipe it. The answer? An event. An event is a special kind of delegate wrapper that restricts direct invocation, giving us safe, decoupled notifications. Actually, scratch that. Think of it more like a bouncer for your VIP list. Under the hood, yes, it's still using a delegate to manage the list of methods, but it wraps it in a strict set of rules about how the rest of the application can actually interact with it.
Let's put them head to head to really see the difference. With the unprotected delegate, external classes are running wild. They can freely invoke it or completely wipe it out using that equals operator. But add the event keyword, and suddenly the C# compiler steps in and enforces a new law. With a protected event, external classes can only subscribe using += or unsubscribe using -=. That's it. They absolutely cannot wipe the list. And most importantly, there is no way they can invoke it. Only the class that actually declared the event has the power to raise it.
Part 3. The publisher-subscriber model.
With our list totally secured, we can now safely build out the publisher-subscriber model.
This is a brilliant architectural pattern that lets a class notify other objects when something important happens without all those objects getting tangled up and tightly coupled together. You've got the publisher, that's the class sending the notification, and you've got subscribers, the class is receiving it. The huge win here is that it safely implements the observer pattern. The publisher doesn't need to know a single thing about who is subscribed. It just shouts into the void, "Hey, my state just changed," and anyone listening gets the message. It makes your system incredibly clean and scalable.
I absolutely love the radio tower analogy for this. Think of the tower as your publisher. Its one and only job is to broadcast the signal when it's time. The listeners out in the world, those are your subscribers. They can choose to tune in by subscribing with plus equals, or they can tune out with minus equals. But here is the security patch in action. The listeners cannot hijack the tower, right? Someone sitting in their living room can't force the radio tower to suddenly broadcast a signal, and they definitely can't kick other listeners off the frequency. The power stays completely with the tower.
And listen, this isn't just theory. This is a huge deal for your career. As one interviewer put it, they want to see if you understand object-oriented programming principles and how to design reusable, maintainable code. This is exactly why technical interviewers will hammer you on the difference between a delegate and an event. Literally anyone can write code that sort of works. But knowing that a public delegate violates encapsulation and knowing exactly why you use an event as a protective wrapper, that proves you actually understand architectural decision-making. It shows you know how to bulletproof your code from unintended side effects in a real production environment.
So to wrap this all up, consider this your architectural cheat sheet. When do you use which? Well, if you're doing functional programming, passing behaviors as parameters, or just setting up a simple internal callback, go ahead and use a raw delegate. But the second you are building system notifications, setting up a publisher-subscriber model, or using the observer pattern across different classes, you absolutely must use an event to keep your state genuinely protected.
Which brings us to our final thought for the day. I want you to go look at the code in your current projects. Are your system's critical notifications truly protected from external hijacking? Or do you have raw, public delegates just sitting out in the open, waiting for some rogue class to wipe your subscribers or force a random system call? It might be time to audit that code base and wrap those vulnerabilities up in a secure event. Thanks so much for joining me on this explainer, and keep building secure, decoupled architecture.